All right, so this morning we're still on 8EE7, but this is us wrapping up 8EE7, the standard, all right? And we're going to be learning how to solve inequalities. First, our first success criteria is I will be successful when I can understand sign changes when performing the multiplicative inverse. So that's one of the first things we're going to look at, which is what happens whenever we perform the multiplicative inverse and the additive inverse when we're solving inequalities. What we've been doing before, we've been solving linear equations, all right? Well, sometimes it comes in the form of an inequality. So I'm going to pull up my whiteboard so that you could see. And we're going to be looking at the additive inverse and multiplicative inverse in regards to inequalities. And it's fairly similar. So we've done questions like this, all right? But we've done them with the equal sign. So when I talk about an inequality, I'm talking about something like if I say 2 plus x is less than 3. And then now my job is to find what is x. All right, that's literally it. So just like how I would solve a regular linear equation with a one-step equation like this, I would do the additive inverse. I need to get rid of this 2, so I do minus 2, and whatever you do on one side, you got to do it on the other side. So then I'm left with x is less than 1. That's my answer. That's us applying the additive inverse, all right? That's us applying the additive inverse. I'm going to do another problem. Let's put a line through here. Okay, and then z minus 4, right, that's a 4, is, let's use a different color, is greater than or equal to 8. And then my job is to solve that problem. Greater than or equal to 8. What is z? That's what they're asking me. So the first step is to do the additive inverse. I need to get z by itself. So I do plus 4. And what do we do on one side? Sure enough, got to do it on the other side. So then I do plus 4 on both sides. This becomes 0. The additive inverse is always equal to 0. So this is 0. So z is greater than or equal to, that's what that sign is, greater than or equal to. And then 8 plus 4 is 12. I'm going to give us a couple seconds to write that down, and we'll work these problems some more. This is just an introductory video for us to watch. We could go back, rewind. But similarly to if this had an equal sign, I would solve it the same. Are we realizing that these are being solved the same way whenever we're doing the additive inverse? Now, let's look at what happens when we're doing the multiplicative inverse. Question mark. Oh no. I want to make this bigger. There it is. All right. So when we're talking about the multiplicative inverse, we're talking about a question like 2x. Let's do negative. Let's do 2x is less than or equal to 4. Could someone put in the chat real quick, just like how if we had 2x equals 4, what would I do to solve for x? It's the same procedure. What would I do to solve for x if I had 2x is less than or equal to 4? Could you please put it in the chat? I'll see what you said once I open it. There it is. What would be my first step if I'm trying to solve this one right here? I'm trying to find what x is. Yes, that's correct. I will do a divide by 2 on both sides. So x is less than or equal to 2. This is what we're talking about inequalities. Not hard, right? Let's do another question, but this time we're going to throw a curveball. So we're going to do negative 2x is less than or equal to 4. So with the same procedure, I have to divide both sides by negative 2 because I want x to be by itself, right? So then I'm left with x, right? And because I'm dividing by a negative number, the 2 is negative, right? Because I'm dividing by a negative number, I have to change the sign. Whoop. So it becomes x is greater than or equal to negative 2. It's only because I divided by a negative number, all right? Over here, I was dividing by a positive number, so I didn't have to switch the signs. But because I was dividing by a negative number, the signs would switch. I want to do another one, but this time let's do x over negative 2 is less than 6. X over negative 2 is less than 6. So again, I'm trying to find what x is. So in order to do that, I need to get rid of this negative 2 that's at the bottom. All right. Since it's dividing by negative 2, I have to multiply by negative 2. So it's going to be negative 2 times x over negative 2 is less than 6. And whatever I do on one side, sure enough, got to do on the other side, times negative 2. So this, we know the multiplicative inverse is always equal to 1. So this becomes 1x, or we just say x. However, we're multiplying by a negative number, so the sign is going to change to a greater than. So x is greater than 6 times negative 2 is negative 12. So what I want us to take away from this, I'll give us a couple seconds to write that, but I'll put the text down here. Let's put this in a different color. When dividing, oh, can't spell that, or multiplying by a negative number when solving inequalities, the sign is flipped. So if I multiply and divide it by a negative number right here, the sign is flipped. All right, sign is flipped. That's basically what we're talking about, the multiplicative inverse when solving inequalities. It's honestly it only comes into play whenever we're dealing with the negative numbers. If I was solving regularly with a positive number, you realize the sign doesn't change, but when I introduce a negative number, it changes. So when I'm dividing or multiplying by a negative number, when I'm solving inequalities, the sign is flipped. All right, we can't forget that. But if you have any questions or anything, let me know, please.